In this movie, we're going to create a reasonably complex QFN footprint to show various techniques that help make the job easier. There are two chapters to the movie. The first chapter covers basic techniques for creating a footprint. The second chapter shows how to set custom paste mask and solder resist and how to define stitching vias. Let's start creating our footprint. The first thing to do is place the pads. Pins are 0.25mm by 0.55mm and we can place pin 1 directly. We want a rounded corner for the rest of the pins, so we next need to create a new pad style. The dialog form is fairly self-explanatory. We don't need a large solder resist expansion on the pads, and we set a bend radius to corner the ends. We now need to place one of the pads underneath pin 1. The pitch on this part is 0.5mm, so it will be helpful to set the coordinate system metric and then use the 0.5mm snap setting. This means we are placing the pad 1 grid square down from pad 1. As these pads are closer together than default design rules, you are likely to get DRC errors during placement. You can turn the DRC off if you prefer during the creation process. Now we can use the replicate command to make life easier. We right-click on the pad, select replicate, and with a Y offset of -0.5mm, copy 14 more pads. This gives us our first row. Next we block select the bottom 15 pads with an X offset of 8.7mm to make the adjacent row, and then add the loose pad to complete the row. The datasheet tells us we have a drop of 0.6mm and an indent of 0.6mm for the other rows. After changing the snap settings to a fine snap, we set a false origin on the pin. The go to position command then lets us move the mouse to the correct location for placing the pad. From here it's the same procedures as before. Replicate 15 pads to form the row and then replicate the row up by 8.7mm to complete the land pattern. We'll come back and deal with the central thermal pad later. The next task is to number all the pads, and to help us do that we use the auto name generator from the tools menu. Leave the string blank and the count as 1. Click OK and then move the mouse over pin 1. A green equals sign beside the cursor indicates that an assignment will be made, either when the enter button on the keyboard or a left click of the mouse is made. The trick is to make sure that our snap setting is at 0.5mm before we start. The keyboard arrows will then directly navigate us from pad center to pad center, and we can hit enter to assign at each stage. Having added the parts, we now need to add some Silkscreen graphics. We'll use 2D graphic lines on top silk to create a little corner graphic. Once that is in place, block copy will duplicate the graphic in the other 3 corners. Block rotate on the 3 copied graphics will then orient them correctly. And we can use the 2D graphic circle to place our pin 1 marker. It's worth at this stage a little detour to show you how to view the paste mask and the solder resist. Assuming you have hardware accelerated graphics, you can do this directly from the Edit Layer Colors command on the View menu. Left clicking on the status bar is a convenient shortcut to this dialog. Make sure that the 2 checkboxes for solder resist and full solder paste are enabled. These will be greyed out if your graphics card doesn't support hardware acceleration. Switch to the Through View setting tab and drag the resist slide up to maximum to see the resist plot for the land pattern. You can repeat for the paste mask slider. We now need to put the large thermal pad down in the middle of the courtyard. This is a 7.1mm square, so we'll need a new pad style. Do this in the same way as before. This time we'll leave the 10th guard gap in to ensure good contact and set the automatic paste mask to be off. Most datasheets now specify a stippled or patterned paste for these pads, so we'll need to set that up manually later. We set the false origin again on pin 1 and double check that we are on fine snap before we move the cursor. A little maths then gives us an X offset of 4.5mm and a Y offset of -3.75mm to the centre. The Go to Position command with these values lets us drop the pad in the right place. Finally, we find the centre of the pad with the mouse, much easier after toggling to the larger snap setting, and set the pin number as 65. There is little point in adding stippled paste until we have our stitching vias in place, as we would want to keep them separate. Select Via Mode and V40 Via Style, then place one near the top left of the thermal pad. We use the same technique as we did for placing the pads, first replicating a row and then selecting the row and replicating downwards. Once we have our via grid, we need to make some space for the paste mask blobs. Right-click to delete vias according to the datasheet. The selection filter is helpful to exclude a selection of pads in order to delete the via in the middle. To specify paste mask manually, we select 2D graphics and change the layer to top mask. Aries will take care of flipping a resist and mask if the resulting package is placed on solder side, so we don't need to worry about that. We set out a small box in the first gap, resize as required, and then make the fill style solid. Block copy will then fill the other gaps. When we are done, we can use the live preview to verify the paste mask and resist. It could also be useful to view in 3D. Place a board edge around the part and then launch the 3D viewer. To finish the footprint, place an origin mark at the centre of the thermal pad and remove the false origin from the board. Now that everything is in place, we can go ahead and make the package. Switch to selection mode, drag a box around everything and launch the Make Package dialog. Give the part a sensible name and description and add to one of your user libraries. Details on the 3D model parameters are given in the Aries help documentation and can also be found in the support movies on the user forum. If we make our board a little bigger, we can then select package mode and place the finished part.